Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12 Physics Alternating Current Chapter 7 NCERT Solution Part 2. Before we start, we have a humble request for you. Please subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever any video is uploaded by us. Let us start today's class. In the last session we have done till question number 7.5. Today we'll start with question number 7.6. Question is obtain the resonant frequency omega r of a series LCR circuit with L is equal to 2.0 H, C is equal to 32 microfarad and R is equal to 10 ohm. What is the Q value of this circuit? So let us see the solution. 7.6. So let us write the things which are given in the questions and which are known to us. So first thing is inductance. Inductance L is equal to 2.0 H. Capacitance C is equal to 32 microfarad, which is equal to 32 multiplied by 10 to the power minus 6 farad. Resistance R is equal to 10 ohm. So resonant frequency is given by the relation you have to remember this relation. You have to remember this formula. Omega r is equal to 1 upon under root LC. So you have to remember this. Now putting the values, we'll get is equal to 1 upon, instead of under root, instead of L we'll put the value, instead of C we'll put the value, which is equal to 1 upon 8 10 to the power minus 3 which is equal to 125 radian per second. Now Q value of the circuit is given as, you have to to remember this formula also. Q is equal to 1 upon R under root L upon C. Now 1 upon R will write 10 under root 2 upon 32 multiplied by 10 to the power minus 6. 10 to the power minus 6, which is equal to 1 upon 10 multiplied by 4 to the power 10 to the power minus 3, which is equal to 25. Hence the Q value of the circuit is 25, and this is the answer. So this sum is based on two formulas. If you remember the formula for Q and the formula for WR, that is resonant frequency, then just put the values, you can find it out, the answer. So let us move to the next question. Our next sum is 7.7. A charged a charged 30 microfarad capacitor is connected to a 27 mH inductor. What is the angular frequency of free oscillation of the circuit? Let us see the solution. Now 7.7. So let us first write it down, all the known values which are given in the questions. So first is capacitor capacitance is given, C is equal to 30 microfarad, which is equal to 30 into 10 to the power minus 6 farad. Inductance inductance L is given as 27 mH, which is equal to 27 multiply by 10 to the power minus 3h. Angular so these values are given. Now angular frequency angular frequency is given as formula is omega r is equal to 1 upon under root LC. Put the value of L and C, will get under root 27 to the 10 to the power minus 3 multiply by 30 10 to the power minus 6. Upon solving, we got 1 upon 9 into 10 to the power minus 4, which is equal to 1.11 multiplied by 10 to the power 3 radian per second. Hence, the angular frequency of free oscillation frequency of free oscillation oscillation of the circuit is 1.11 multiplied by 10 to the power 3 radian per second. Hence, the angular frequency of the oscillation of the circuit is 1.11 multiplied by 10 to the power 3 radian second, which is the answer. So let us see the next problem. The next problem is 7.8. Suppose the initial charge on a capacitor in exercise 7.7 is 6 microcoulomb. What is the total energy stored in the circuit initially? What is the total energy at later time? Let us see the solution. So, solution of 7.8. Capacitance. So first we'll note it down all the known values from the problem. So first known value is capacitance. Capacitance of the capacitor C is equal to 30 microfarad, which is equal to 30 multiplied by 10 to the power minus 6 farad. Next known value is inductance inductance of the inductor which is L, which is denoted by L, and L is equal to 27 mH, which is equal to 27 multiplied by 10 to the power minus 3 H. Charge on the capacitor. Charge on the capacitor Q is equal to 6 mC, which is equal to 6 multiplied by 10 to the power minus 3C. Now we have to calculate total energy stored in the capacitor which is E is equal to half Q square upon C. Here you have to remember this formula. Once you remember this formula, just put the given values, you can find out the answer. So which is equal to half Q square's value is 6 into 10 to the power minus 3 whole square. Again, C's value is 30 multiplied by 10 to the power minus 6. Upon solving, we get 6 upon 10, which is equal to 0.6 joule. Now total energy at a later time will remain same because energy is shared between the capacitor and inductor. So this is the answer. Let us see the next question. Now we'll see 7.9. A series LCR circuit with R is equal to 20 ohm, L is equal to 1.5 H, and C is equal to 35 microfarad is connected to a variable frequency 200 V AC supply, 200 volt AC supply. When the frequency of the supply equal to the natural frequency equal to a natural frequency of the circuit, what is the average power transferred to the circuit in one complete cycle? So let us see the solution. So this is the solution of 7.9. At resonance, the frequency of the supply power equals supply power equals the natural frequency. So at resonance, the frequency of the supply power equals the natural frequency. Natural frequency. Natural frequency of the given LCR circuit of the circuit. So resistance, now we'll put down all the given values. So resistance R is equal to 20 ohm. Inductance L is equal to 1.5 H. Capacitance C is equal to 35 microfarad, which is 35 multiplied by 10 to the power minus 6 farad. Now AC supply voltage to the LCR circuit LCR circuit V is equal to 200 volt. Impad impedance of the circuit is given by is given by the relation Z is equal to under root R square plus XL minus XC square. So you have to remember this formula. Now at resonance, so at resonant at resonance XL is equal to XC. You have to remember this. XL at resonance XL is equal to XC. Therefore, Z is equal to R is equal to 20 ohm. So which is equal to 10 ohm. Now current in the circuit can be calculated as I is equal to V by Z, which is equal to 200, put the value of V, and 20 the value of Z, is equal to 10 ampere. Hence hence the average power hence the average power transferred to the circuit transferred to the circuit in a complete cycle, in one complete cycle. Cycle in one complete cycle, Vi P is equal to Vi, which is equal to, put the value V and I, that is 200 multiply by 10, which is equal to 2000 watt, which is equal to 2000 watt. And this is the answer. And this is the end of today's session. Please subscribe, like, and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and for your support. Thank you.